For each problem that you missed on the final, I expect you to follow along with my corrections, write the correct work on the back neatly, and turn it back in at the end of the period or whenever you're done. Once you're done with this, I need you to watch the video on section 7.2 and try the homework that's assigned to McGraw-Hill. So how do we do these problems? Well, we want the area of this parallelogram. The area formula for a parallelogram is base times height. It's the same as a rectangle because if we took this part of the triangle off and we drew it right over here like this, redraw right there, then we have a rectangle. And let's see if I can shade this in red. Okay, now you don't have to really cut that off, that part of the triangle. You can just get the height of the trapezoid. That's the height right there. And this is the base over here, and you just plug them into the formula. So we ended up with, on this case, the base being 24. And the height, well, we don't know what it is because they didn't give us this length. But 9 something 15 triangle, because 9 something 15. This is where the height's going to go right here, right? So how do we do this problem? Well, 9 and 15 are both divisible by 3. So I'm going to divide by 3 and end up at, let's see, 9 divided by 3 is 3 something, and 15 divided by 3 is 5. Well, 3, 4, 5 is a poster on the wall over there, meaning it's a Pythagorean triple, meaning these are the 3 sides of a right triangle. And they happen to be whole numbers, which is super nice. And so we recognize hopefully that. Now to get back to the triangle that we care about, we multiply by 3 because we divided by 3 to make it a triangle, or 3 sides of a triangle that are on the poster over there. So we got to multiply by 3 to get back to our original triangle that we care about. So that becomes 12. 4 times 3 is 12. So I'm going to put 12 right here for the height. Now I do know 12 times 12 is 144, but 24 is twice as big as 12. So 2 times 144 is 288, which is this answer right here. Hope I made that clear. Number 2, it wants us to identify CD. So let me highlight where CD is. CD is this piece right here. That's the side. That's a side in that pentagon. See, it says, we got this regular pentagon, right? And CD is a blank of the pentagon. So if they were wondering in this triangle, what is CD? Yeah, that could be the base of a triangle, but it's saying, what is it relative to the pentagon? So it's a side in the pentagon. And then it asks us, oh, shoot, I put side on the wrong blank here. Let me try that again. Side goes on this blank right here. All right, now it says, what is FG? So let me highlight FG in blue. We've talked about the apothem a whole bunch. We've been trying to find the apothem right there. And thankfully, you guys did really well with this. That's the apothem. Okay. This side answer really messed some people up. A lot of people thought it was the base. It is the base of the triangle, but they're asking about the pentagon. So you would have got a 5 out of 6 if you would have chosen base, because that's a small little mistake, right? So out to the side of each one of these problems, you see a score out of 6. And a 5 would be if you chose base right here instead of side. And a 5 is equal to 90% on this problem. That's just a small mistake. I can understand why you chose base there. I hope I'm making my grading system clear there with that 6-point rubric. Those are the correct answers over there. So you should see a 6 out to the side of this problem if you have both those answers. Let's go back to number 1 here real quick. Number 1 was, all these problems are out of 6 points, okay? So there are 6-point scores for a total of 36, and we'll look at that at the end on how to figure out your percentage. Number 3, well, we want the lateral area of the prism. Okay, lateral area is the perimeter of the base. This triangle is the base. Well, that's one of them. There's a base in the back too. It's laying on one of its lateral faces. So really we need to imagine that thing being stood up. If we think about the base as the top and the bottom of the figure, but you don't have to think about the bases as the top and the bottom. In this situation, you can see that cross-sectional cuts perpendicular to this 12 side would give us this triangle right here. So we'd have triangles, triangles, triangles all the way to the back. So the two sides that are parallel and congruent to each other, those are the bases in a prism. Well, if this side over here is 10 long, we've got a 6, 8, 10 triangle, just like we had on problem number 1, I think it was, right? Where we had a 3, 4, 5 triangle, which is just twice as big as a 3, 4, 5 triangle. So the lateral area formula is the perimeter of the base times the height, and the perimeter of the base is 8. 8 and 6 is 14, plus 10 more is 24. So I'm just going 6 plus 8 plus 10. That's 24 for the perimeter of the base. And the height is 12. Hey, that 288 number is coming up again. 288. Okay, we saw that in problem number 1. So blank number 1, 288. That's the lateral area. Okay, let me put that on my blank number 1 over here. 288. Okay. Now it wants the surface area. So we got to add the two bases. So the front base, okay, so base, it's a triangle. So that's 1/2 the base of the triangle times the height of the triangle. That's 1/2 6 times 8. Okay, 6 times 8. Probably should put it like this. Okay, that's 48. Half of 48 is 24. Okay, so one base is 24. So I'm going to put for my surface area, I'm going to put the lateral area, 288. Okay, and then I got to add two bases to it, two 24s. Why two of them? Because there's one in the front and there's one in the back. So that makes a total of 48, which I think comes out to be 336. I think it's 336 when we add those up. I hope I'm doing my arithmetic correctly. If I remember the answer right, I think it was 336, wasn't it? Now it says calculate the volume. So the volume formula is area of the base times the height. The base we just got is 24. So 24, we're going to take 24 times 12. Notice that this gives us 288. Okay, now how can that be? How can the volume answer be the same as the lateral area answer? That's because I've been kind of ignoring the units here. This is inches, right? So my lateral area is in square inches. My volume, because it's inches, that's cubic inches. Okay, so they're very different measurements, even though the number is the same. 280. Oh, gee, many square inches here. Okay, I should have 336. Oh, see right there. Oh, yeah, the units are listed right there. So they're not listed for some reason down here for the volume. Anyways, number 4, we want the same three measurements, lateral area, surface area, volume, but the formulas change. The formula is a little different. It's 1/2 perimeter of the base times the slant height. So I go 1/2. Okay, let's see here. 10, 10, 10, 10. So the perimeter of the base is 40. So I'm going to go 1/2. That's a bad looking too. 40 times the slant height. This is the slant height right there, 9. Okay, 1/2 of 40 is 20. 20 times 9 is 180 square inch. It's in centimeters. Square centimeters. Okay, so come on. Square centimeters. All right, so I'm going to put 180 right there. Okay, surface area is the lateral area plus one base, because there's only one base in this object. So I'm going to go 180 plus 10 times 10, because it's a square. 10 times 10 would give me 100. Okay, so I get 280 square centimeters. Okay, so 280. Let me put a little note over here. The base is equal to 10 times 10, which is 100 square centimeters. All right, here comes the volume. Volume formula is 1/3 area of the base times the height. Ooh, now this is tricky because we have the base. That's no problem. I already calculated that. But the height, oh my goodness, the height goes right to the center of the base. Let me put it in blue. See if this stands out for you. Okay, so that is the height of our pyramid. So what do I need to do? Well, I need to get this little red dash segment right there. It's half of the 10 segment. So this part right here is 5. The hypotenuse is 9, and I need to know what the height is. So I'm going to go like this. H squared plus, oh, I switched to red, plus, let's see, it's h squared plus 5 squared equals 9 squared. So 5 squared equals 9 squared. Pythagorean theorem, right? Leg squared plus leg squared equals hypotenuse squared. So I get h squared plus 25 equals 81. I subtract 25 from both sides, and I get h squared equals 76. I take the square root of both sides, and I get square root of 76. That's going to go right here, square root of 76. Okay. Now, if we want a decimal approximation, which I think we do because we want to round to the nearest 10th place, right? I need to get a Desmos screen over here, Desmos, right? And I would do 1/3. So 1 divided by 3, arrow to the right. Now, let me look back at my formula again. What did I want to do? I wanted to go 1/3, 100 times square root of 76. So I think I could just put 100 right now, but it makes me a little nervous. I'm going to do times 100. And then I could definitely do SQRT because it thinks, okay, I'm going to take 100 times square root. And the answer, what was underneath square root sign? 76. That's not right. It's 56. Come on, Nelson. Come on, Nelson. This is 56 right here. My goodness. I wrote down 76. This is 56 right here. Okay. So this right here, 56. Sorry about that, folks. I hope you were screaming at the screen. Nelson, it's 56, not 76, you ding dong. Okay, so here we go. I got to get a 56 underneath my square root sign. 249.4, 249.4, 249, 249.4. Any questions about how I got that answer, or if you think I did something wrong, you shout me down during class, okay? Because there's a lot of places to make mistakes in there, right? You should see a score out of 6 on the side of this problem. You should see a score out of 6 on the side of this one. You might have got a 5 out of 6 if you showed a lot of this work, but maybe you made a mistake right here with the 56 like I did. Maybe you put 76 or something silly like me. Hey, thanks for watching so far. You're doing fantastic. Keep it up. This one right here, could you imagine there's another side once this thing revolves is the word that Rhino uses. This one's saying rotates around this line, right, by rotating. And that would make a sphere. If you want to make it look three-dimensional, you would draw in kind of this like equator in the middle. This one right here, if you imagine it getting reflected over the line first, that might help, like I reflected that guy. And then you got to imagine it getting revolved or rotated about the axis of symmetry, and that would make a cone. So this one's a cone, this one's a sphere, and then this one's a cylinder because look at the cross-sectional cut's just going to be a rectangle, right? And you guys are doing really well with this. A lot of people got this one right. So this top, I'm going to make it look like you can see the whole top, but you can't see part of the bottom down there. So this one, hopefully believe me that it's a cylinder after I draw that. If I'm not making this clear, again, call me over. Let me know. Oh my goodness. This one was the one that we practice because it's a pentagon. It makes things difficult. But hopefully you had some notes on this pentagon, and the notes that were really important to have were this piece of information, these pieces of information right here. This is a 54-degree angle right there. This is a 36-degree angle right here. So we cannot use like 30, 60, 90 triangles. We can't use Pythagorean triples. This is a situation where we got to use SOHCAHTOA, sine, cosine, or tangent. The whole side length is 6, right? So 6 is right here. So I'm getting ahead of myself because I can get the lateral area. I can get the lateral area without finding anything particular about the base. Well, I need the perimeter of the base, but it's giving me a side length. So there's 6, 6, 6, 6. There's 5 6s going around the base. So the perimeter is 6 times 5. Since there's 5 sides at 6 each, that's 30 inches. The lateral area is the perimeter of the base times the height. And they gave me the height right over here, right? So I just need to go 30 times 8. So this is what I'm talking about, like on math tests. Don't give up, thinking, oh my gosh, I can't do number 3, because there might, be one at the end that's very doable. That's for you, like easy. You're like, oh, I know perimeter times height, and I can get to perimeter pretty easily, right? This is deductive reasoning. We're trying to get smarter doing deductive reasoning tasks. Okay. All right. Well, let's see. I know this piece right here is 3 long because I now need to get the base, right? Because surface area is this answer right here, the 240 number. And I've got to add 2 bases to it. So I'm going to take 240 plus 2 times whatever I get for the area of the base. And if this is 3 and this is adjacent to the 54-degree angle, and then the side I'm looking for is the apothem, I need to use tangent. And I could use 54 or 36, but I like 54 because the apothem is opposite from the 54-degree angle. It's the opposite leg. 3 is the adjacent leg. So in SOHCAHTOA, tangent is the last 3 letters. This means that the tangent of an angle is equal to the opposite leg over the adjacent leg. Okay? Now, I've got it set up here. This is my setup. I love it when I see people write this down. What I need to do now is to solve it, I need to multiply both sides by 3. So I'm going to make a separate line of work here. And I get 3 times the tangent of 54 because these 3's divide out to 1. I get the apothem is equal to 3 times the tangent of 54. So I jam over to Desmos. I switch. This is super important. I switch to degree mode. And I type in here 3 times the tangent of 54. So my apothem is 4.1. Now, it's okay if you put 4.1 on your paper to show a little work, but I would not use 4.1 in further calculations. What do I mean by that? Well, the base is 1/2 the perimeter times the apothem, since it's a regular polygon. So I'm going to go 1/2. I already calculated the perimeter. That was 30, right? So I put 30 for the perimeter. Now the apothem, I can put an approximation on my paper, but I'm definitely not using that approximation. I'm going to use this 3 tangent 54 number. So really what I'm saying is the base is approximately this, but if I use this 4.1 number, I might be further off than I'm allowed in the tenths place. So I'm really going to put on Desmos 1/2 30 times 3 tangent of 54. Okay, that's a 4 right there, doggone it. Okay, so here we go. Hey, I already got the 3 tangent 54. What do I need? I need a 30 in front of it, and I need a 1/2. Now, the safest thing to do is to make it look exactly like I've got it written over there. So I'm going to put in parentheses here a 30 right there, right? That was the perimeter. And then the formula is 1/2. So I'm going to put a 1/2 in front. This should be the area of my base, 61.9. Okay. Again, I'm going to put down approximately 61.9 on my paper, but I'm not going to use that right there. You know, I'm going to use all of this stuff on Desmos right there. But on my paper, it's okay if you write 61.9. So you have some idea like what the heck is going on here. So I want to go 240 plus. So in front of this stuff, I want, oh, wait. Yes. I want 240 because my lateral area was 240, right? Notice anytime you switch between screens, it puts the cursor at the end. So I want the cursor all the way in front. So I'm going to go 240 plus 2 times. Now you might say, wait, I know what 2 times 1/2 is. That's 1. You're welcome to get rid of that. I'm not going to see what you put on Desmos, right? But now I know that 330 or 363.9 is the answer to the nearest tenth. 363.9. Then what I do is I double check it. 363.87. Yes, I round up to 9, right? Okay, so I've got my surface area correct. Now look, volume is area of the base times the height. Well, I just got the area of the base was 61.9. It's okay if you write it on your paper, 61.9, but I'm not going to take 61.9 times 8. I'm just going to jam over to Desmos and get rid of some of the stuff that I don't want. I don't want that there. Now there's the area of the base, right? I want that whole thing times the height, which was 8. Okay, so I got my 61.9 number. It's okay if I put the 8 at the end. So I'm going to go times 8. This is my volume, 495.5. 495.5. Guys, I need you to be nice to yourself. 495.5. I know you're thinking, maybe some of you, That's too much, man. Nelson, I can't do that. I think you can. I know you can. And so I want you to be nice to yourself and give yourself a chance. You're fantastic. Give your brain the credit that's due to it. You can follow along with this. You can do this if you practice enough. I know we might not have practiced enough, but I really appreciate you, and I know you can do it. So thanks for putting all the corrections down. I want you to now watch the video on how to do section 2, chapter 7, and start on your homework. Thanks, everybody.